Hey guys. So I'm Nick, and today I want to introduce you to web components. And I would like to start about a short introduction about myself. So I'm a co-founder and a development lead at Blossom. It's a lightweight project management tool for people who create software. And it visualizes a feature pipeline, and it is used by internal teams at Twitter and Netflix, which I'm really happy, and startups like ourselves, which are smaller. And at Blossom, we always we love simplicity, and we always strived for easier ways and more beautiful ways to create web applications. And so on our way, we have a single-page application, and on our way to now, we about 2 years ago, we created Branch, which is an application assembler. So we did a lot of JavaScript, which was backbone CoffeeScript. And this assembler has over 2,000 GitHub followers now, and is used by Uber, Delicious, and so on. And earlier this year, we decided to move on. We moved on to Dart and web components. And Dart is a new programming language by Google, which is, or a lot of mostly the Google guys are behind that, and but that's a different story, probably for this evening. And so let me get started with web components. So web components, what are web components? Web components, basically, it's a new standard evolving, which allows us to create our own encapsulated custom elements. So, but this is happening natively in the browser, so it's becoming a standard. And what does this mean? I mean, I can basically build, I can import, and I can use my own custom elements. And the special thing about these custom elements, there's no styling leaking out. The internal DOM is hidden. And think about the video tag. A video tag has, to give you some example, a video tag has some logic. You can press the play button, then it plays. There's a slider, you can turn on the value. So there's business logic in this video tag we are using. And we can build such tags by our own in the near future, or actually today. And how to use that? It's really simple. So you just can import your own component, or a component someone else built or you built, and then you can just use it, your custom calendar. And what you will see is a calendar. But we can do the same for a map or anything else. In this case, I used an OpenStreetMap example. So I built my own map element, and I can just import it. I can import it, and I can use it. And I even can define attributes. So I set the location to the center of Berlin and set a zoom level of 5. And well, again, it's a map of Berlin. And just to stress it, this is becoming a native standard in the browser. And so to become a native standard, you have to have some support. And the guys from Google, the Worldwide Web Consortium, and the Mozilla, they're putting a lot of effort in it to make that happen. And we already also have support from Ember, Angular.js, or Dart. And for example, Angular 2.0 will really tightly integrate into web components. So it will be tightly coupled, and I'm really looking forward to that. So why do we need web components? I mean, basically, what we can do today is we can create calendar widgets. We have maps. We all have that kind of stuff. But if you think about, if you want to build scalable, maintainable applications, that's hard today. We came up with patterns and conventions to actually solve that problem, because currently the DOM is global, our styles are global, and also our JavaScript namespace, that's global all the time. And we came up with things, for example, in CSS. So what we do, which is perfectly valid and works really quite well, is we do nesting. So we have we define a headline and say this H2 has a color red, And if I have something somewhere else, I apply a class. And then I say, OK, this class, if it's an H2, then it's fine. And I want to have it blue. But that's like the list gets longer and longer and longer. And that's not something you actually want to do, because you just want to say, OK, I have this widget, and inside this widget, my headline should be blue. So, as I already mentioned, with web components, we get encapsulation. And that's like the really, really important benefit of web components. So you don't just, once again, the styling doesn't leak out. If you have the DOM, if you search for something in the DOM, you won't find content inside the web component. And of course, this makes them really, really easy to reuse. And composability is also really great. And this makes prototyping extremely fast and easy, because you have widgets are defined in natively or with a native API. So I can build a Bootstrap model. I don't have to include any kind of Bootstrap JavaScript or styling. I can just include the Bootstrap model, and then inside I can use the map I used, and I can also use the headline I used already, the header. And that's really cool, because with all the frameworks and all the different all the different frameworks today, for example, if you have a Dojo widget and you have a jQuery widget or an Ember widget, they probably won't work together. It's hard to do, and with web components, it should become much, much, much easier. And so prototyping becomes easier, but since you're all programmers, I want to actually show you something what's behind that. And interestingly, it's not a single specification, the web components, but a World Wide Web Consortium. It's actually an umbrella term for several technologies. And today I want to introduce you to these 4 technology areas which are new. The first one is HTML templates. It's basically inner chunks of clonable DOM. It's custom elements, so I can define my own elements. It's the shadow DOM, which gives us the encapsulation. And HTML imports to import other HTML documents. And let me start right away with HTML templates. Today, we have client-side templating. So what we do quite a lot is we have script tags, and in there, for example, we use the type, and we have type X handlebars template, for example. Have some content in there, and we can fetch this. We can query for the script tag and then use it, and in HTML we can append it to the DOM. But this with user-supplied data, this can lead to, it opens up an attack vector for cross-site scripting. So we have to escape all our content from the users. And that's, again, something which shouldn't be there. It should be done properly. And what we will get is a native template tag. So a native template tag, and the benefits of this native template tag are we're directly working with the DOM. So there's no runtime script parsing. It's hidden from the document, so you won't. If you query for it, you won't find it. Actually, you can query for the template tag, but you can't find anything inside it. What does it mean? If I have this class hour, unless I used it somewhere and put it actually in the DOM, I won't. If I query for an hour, a class hour, I won't find it. It only becomes active if I append it to the DOM, to the document. And that's interesting because also content gets parsed but not rendered. That's important. Images images aren't loaded, script tags aren't executed. You can have multiple script tags. And media doesn't play. So it's rendered, it's parsed, but not rendered. So that's HTML templates. The next technology is Shadow DOM. And Shadow DOM is this key technology which gives us encapsulation. And the Shadow DOM creates a self-contained document-like subtree. And this subtree is called shadow root. And this shadow root gives us CSS style boundaries. And this is really the key to build large applications. And so you get a feeling about the Shadow DOM, what it means. Browser vendors are using Shadow DOM since a really long time. And I can demonstrate it with the video tag. So you know the video tag, they have some controls here. That's just the video tag where I define the source and I have a video. But there's something interesting. For example, if you look in Chrome and you activate Show Shadow DOM, so what we start to see here is a document fragment. So we can look inside the Shadow DOM, and we can actually figure out and see how the browser vendors build their controls. So in here we see a button. In here we see the range. And we can look inside. And this kind of API, this kind of encapsulation gets exposed to us, web developers. And to give you an example, it's pretty easy to create a Shadow DOM. So in this case, we have a clock, which is just a div, which will act as our host. And we just query for that host and say, host, create shadow root. And inside this shadow root, we can insert any kind of HTML. And what we actually get there is then, in the end, we only see the div ID. It stays the same, but in the visual representation, we will also have the span 14, and it will be hidden inside the shadow root. And I actually want to demonstrate how this encapsulation works with a small example, which is, in here I defined a headline 2. Level 2, which is by default my styling is black. It's a black header. But if I create another element, I create the div with as a host. I create a shadow root again. I apply a styling. So I create the content inside this shadow root, and I have a styling here. So I say my headline level 2 should have the color red. And usually when you define somewhere in your HTML document a style and say the headline should be all, or headline level 2 should be red, it's applied everywhere. And that's where we need the nesting of the classes. But what actually happens here is that the header will stay black. And only the styling I defined here applies only inside this shadow root element. Every content, it's a subtree, a DOM subtree, and it's only inside there. And that's the style boundary we get. Yeah. And so a lot of people argued already when I told them this that okay, but there's an issue. Then I can define my own widgets, but if I want to include them in my site, that's probably bad because I don't like their styling. So creators of web components can allow people, they can create their components in a way that you allow the author styles. So you can say, okay, this component has no specific styling, so I allow every kind of styling to leak in. And there are also some, for example, you also this can be done with the author styles or reset style inheritance. And there's also a new thing for the CSS in the component, which is the host. I mentioned that a shadow root is appended to a host. So I can apply, inside the component, I can apply styling from a host element. And what I really like the most is I can define my own pseudo classes. So I can say in my clock, the hour span, I want to say that this is a pseudo class. So you can say like X hour. And in the index HTML, where I'm using this clock, this my clock element, I can say, okay, that's wrong. That should be my clock, and say like I want to apply for only this pseudo class. I want to apply the color blue. So from outside, I will be able to style only specific things the author of the component allowed me to. And that's really cool. Let me get to the third of these technologies, and that's custom elements. And as it already says in the name, you are able to to register your own elements for the document. And that's a small example. So how do you do that? You basically, the document gets a new method, which is called register. And you can register your own element, where I can also provide a prototype. So I can have my own JavaScript object. And in this case, I created a prototype. I created I also added a created at callback, because these custom elements, if you create a new custom element, there are several callbacks which are called, which are really, really helpful. So the first time there's created callback, there's inserted, there's removed, and there's changed. So every time the component gets inserted into the DOM, this callback is fired. So, and this is really, really helpful. If you want to, for example, if you want to only fetch data, if the component is really used, you can do it at exact that point. And for creators for web components, you can act based on if it's created, inserted, or you can tear down stuff if the component is removed again. And so what we did here is we create an clock prototype, and it's based on the HTML element prototype. We define a callback for the created callback, and say the text content of my element should be 20 past 2. Then I registered it to the document, and that's a way to create this. That's a way to create this. To create an actual object from this prototype, and then I can append it. And what happens? I create a custom clock element with this content I defined, and it's added to the DOM, and it lives there. So the fourth technology, which is new, is HTML imports. And HTML imports, it's pretty straightforward. You can import any kind of HTML document, and you can query for that, and you can query inside that document. So that's pretty basic here. Now let's get to the fun part. Let's actually stitch everything together and create a web component. Because I already mentioned, web component is an umbrella term for all these technologies combined together. And so what we see here is basically creating this, having this template. That's the first technology we mentioned. So we have a template. We can create a new element, which is based on the HTML prototype. And we can query for the template. We create our own shadow root, append all the content, the template content, to the shadow root, and then register it. And after all that stuff is done, so that's a bit code, we actually can use our own custom tag natively in the browser. And usually, when we talk about new technologies, new native technologies in the browser, it's kind of sad because we know that we can't use them in a while because they are not supported and are not fully supported, and probably one browser is doing that, but the other not. But there's an answer to that. So the guys from, there's a project called Polymer, which is heavily supported by the Google guys, by the Mozilla guys. And what they're doing is they're polyfilling all these APIs. So we can use these APIs, the shadow DOM, the custom element, the HTML imports, already today. And that's pretty cool because that means we actually can use web components. And they even do a little bit more work. So on top of that, they created Polymer.js, which is making things a lot easier. And I will demonstrate it in a second. And there's also from Mozilla, there's X tags. So people are already working on libraries, and people are actually working on components. So Mozilla launched, I think, a couple of weeks ago, they launched bricks, which is a set of components you already can use. You just have to include the bricks JavaScript, and you can use all these elements. And of course, there's Google is working on or Google and Mozilla are working on the shims. Then Google is putting a lot of effort in Polymer, already providing us with elements. Mozilla is doing the same. So their Xtext library is at this level and is using the same polyfills. And they're also providing bricks. And there's also, which I'm really, really happy about, that there's a Dart port for Polymer. And they're also putting a lot of effort in there to, and it works really, really well. I'm glad about that. And to give you a demonstration, if you compare, so these are like helpers so you can define your own poly element, and the same thing as I did before, creating my own web component. It's basically a wrapper. They're doing all the things normally you have to do by your own to create a web component, but they make it really, really easy. And the clock I defined for myself, which I can use here, which was all this code. It's getting a lot simpler and easier. And if you want to try out web components, I highly encourage you to try Polymer.js or the X tags because they're making things a lot more easier. And before I'm done, I want to leave you with a final thought of mine. In my career, I've built several things over and over and over again. For example, my favorite example is a login form. For several companies, for several customers, I built login forms, and some of them were better, some of them had a better UX, some of them not, some of them were fancier, some not. And I'm happy about the good ones, but I'm not so much happy about the bad ones. But think about, you can define your own login form, and there's a collection. Someone collects the best login forms out there, and you just look at the page, browse there, and say, OK, that's a nice login form. I want to have that. You download it, and just import the tag and use the login form tag, and you're done. And it's perfect. The UX is nice, so all the interaction is good. You get, for example, a show hide password thing, and you don't have to do that by yourself. And that's just the beginning. And there's no thing like, OK, this is something from a Dojo library, or this is something from Ember, and I can use that in my Backbone app. That's all native, and that's extremely awesome, because we get one platform we can use all. And yeah, thank you very much for listening.